All right, lightning talk. So my name's Harry. I'm from Modelbit. We host custom models that our customers build and deploy with our platform. And so a lot of our customers recently build what's called two-tiered LLM systems. And this is where they have an ML model that they have trained or fine-tuned in-house. And they also have an external system like ChatGPT from OpenAI, where they are deciding at prompt completion time, at inference time, do I want to call my model or do I want to call the external model? And obviously you can generalize this. There might be multiple different backends, 3 or more that you might want to call. And we've helped a number of customers do this now. And we've learned a few lessons, things that those customers might have wanted to know when they started building this multi-tiered system. Just real quick, typical architecture, basic architecture for a multi-tiered system. You're going to have a request come in. Usually from your customer. Maybe you're running a chat bot, a support bot of some kind, request comes in, you're going to have some business logic that decides, do I call model A, model B, model C, where one or more of these models is your own fine-tuned model, and some of these models are external models. So often this is used to bootstrap a system like where you're dependent on OpenAI, and then you want to start building your own model. And so this is used to bootstrap this system. But just as often, this is used just for business reasons, like the OpenAI API might be highly variable in latency or highly variable in stability or too expensive, and you need to start replacing it with your own system. All of these are relatively common situations that we see. And so I'm going to walk through just 10 lessons learned if you're building a system like this, how to not trip over your shoelaces when you do it. Number 1, you think when you're building a two-tier system that you have 2 models. You in fact have 3 models. You have the external model from Gemini, not to just pick on OpenAI all the time, Gemini or Claude or OpenAI. You have the internal model. Then you have the model that decides which model you're going to use. This was represented in my original diagram as business logic, and it starts that way, but then it quickly becomes a rules-based system, and then it quickly becomes a classifier. So factoring that out at the beginning and understanding that you're going to have a third model that you're going to end up wanting to iterate on over time is critical. I'll actually show you an example of this as we keep going. Second thing you want to do right off the bat is create a unified API across all of your models. So you have your products code where you're building this bot, this support analyzer, whatever. You're going to want to call a unified API. Here I've called it get completion, where you pass in the prompt from that product code, and then your 2 or 3 models are running there. This gives you separation of concern, so you can have a separate team that works on this, has its own deployment schedule, its own iteration speed, separate from your much bigger product, so that you can make much faster progress. The next thing that you're going to want to do, and this also applies, I've just kept it simple here for prompt engineering, but this also applies for RAG or anything else that you're doing. You want to separate out your prompt engineering, your retrieval augmented generation on a per model basis. Otherwise, what happens is you start to push improvements to your prompts that you thought in training were going to be accuracy improvements, and they are less improving than you thought they were, or they even degrade quality in production. Because what's a better prompt for Llama 3 might be a worse prompt for ChatGPT. And so you're going to want to separate out the prompt engineering between these 2 models. This also gives you the ability to give more separation of concerns. So you originally wanted to separate this into 2 teams, the product team and the model team. Now you can have a team for the external model and a separate team for the internal model, and they are also able to operate separately. Next thing that you're going to want to do is have a latency-based fallback for the call to the external model. So you're providing a product with a strong product experience, right? So you expect I type in the chat box and I get a response in 2 seconds, 5 seconds. That's really normal. But what you don't want is every once in a blue moon, for reasons outside your control, the user typed in a box and got a response back 30 seconds later, a minute later, 2 minutes later. When you're depending on an external API, that can happen more often than you would like. And so what you're going to want to do is time out the call to the external model and then have it reroute to the internal model, even if it's worse, so that you can have a positive product experience in that moment. By the way, and I know I'm whipping through this lightning talk, but you can see here that I've still got the logic in Python where we wait the 10 seconds and then begin the call to the model. For completeness, really what you're going to want is for this to be asynchronous. So you start both calls simultaneously with the plan to use the external API, And then if the external API takes longer than you would like, you go ahead and return the call to the more predictable, more controllable internal API. I did not attempt async Python on a slide for y'all, but I may do a blog post based on this, so I'll write out the real code. Next thing that you're going to want is to allow model selection overrides without requiring a code validation and a code push. So when you are calling your model, you might think, I've got my business logic or my classifier that decides which model I'm going to call. You might, for business reasons, at inference time, decide that you need to override that decision and force one of the other models to be called. The most common reason for this that we see is the external API is down. OpenAI is down, or Gemini is down, or what have you. And even though your logic might decide that OpenAI is a better choice, you know for sure that you need to rely on the internal model because the external model is down. For most of us, if you're pushing entire product code, that's many minutes of CI/CD and deployment before it's done, to say nothing of all the internal process around code review that might happen. And so in order to bypass that, you're going to not want to require a code push in this moment. You're going to want to be able to say, I want just in the inference call itself or in a data file somewhere that I can easily update, decide which model to use from a business point of view. By the way, one thing I'll say here, if we look at the logic that's deciding which model, we just started with if OpenAI do X, otherwise Y. Now let's look at our if statements. If not, force local model and use OpenAI. If force local model or not and, right? This is what I was talking about in the very first lesson, right? We're starting to see the business logic that decided which model to call become a rules-based system in reality, where it's not just does the business decide to use OpenAI or not, there's all these other things that go into this decision. And so this is why you're going to want to actually factor out that call into its own separation of concerns, where you can have a rules-based system and eventually a trained classifier decide which of these models you want to call in production. Next thing that you're going to want to do is build a throttler for your external model calls. So what I've done here is instead of iterating on the one Python function that we were iterating on, I've now factored out just the call to the external model, just the call to OpenAI. And we've implemented a system where we write down when was the last time we called the OpenAI model, and we know what our rate limit is. So we know if we call OpenAI too fast, that we are going to, we know that if we call OpenAI too fast, that we are going to get rate limit errors and we're going to have to manage that. So to proactively get ahead of that, what we're going to go ahead and do is just queue calls in this function and throttle them and return when we can. This function, you're going to then want to wrap in the timeout function, the timeout logic that called this function. So that if the queue gets too long, you're going to start throwing away calls to the external API and falling back to your internal model over time. And so with that, you can be robust to the particular rate limits and timeouts of the external API that you are not in control of. Next thing that you're going to want to do is shadow all the calls to your local model. So what I mean by that is, let's say you've decided to call the OpenAI API for a certain call. You should also send that inference to your own model, log its response, and then throw that away. This is so that you can improve your own model and know what it would have done. So remember, if we back way up, the goal of this project might have been to bootstrap our own model that might be lower cost or more in our control. And so in order to do that, we're going to want to know what it did, even on the calls that you sent to OpenAI. And so you're going to want to shadow deploy shadow deploy the model, by which I mean send all calls to the model, even if you're not using it. Next thing that you're going to want to do is log all the inputs and the outputs that you were sending to the external API. I'm not going to go so far as to say you should shadow deploy the external API, because that usually comes with a lot of costs. But you are going to want to say, okay, every time I send something to OpenAI, let's log what I sent it, and let's log what it sent back. Why do you want to do this? I am not a lawyer, so I could not tell you if this is for your own training data, but I think it's a good idea. Next thing. Do not use one model to tell you if another model is a good idea. This is where you start chasing your tail and going in circles. And it's weird. My Llama model is becoming more like ChatGPT, but now my ChatGPT responses are becoming more like my Llama model. You need an external ground truth for what is good and what is bad. Best option here is to ask 1 in 10 or 1 or 100 of your users Did you like this experience? Did you like the response you got back? Yes or no? Second best thing is to have human raters. But either way, what's really important is to establish a ground truth that is separate from model responses so that you know if you are getting better as an overall system or not. Last tip for y'all is just something a little more strategic. It is really common for these teams as they work over a period of weeks or months to be really proud of how accurate they have made their system or how much they have minimized the drift in their system. But these projects are usually started for strategic business reasons, not just for technical reasons. So the goal isn't a high accuracy system. The goal is something like not having our business be dependent on an external partner that might turn us off. Or not sending our data to a company that might decide to compete with us. Or something more simple and pedestrian like we just want to reduce our costs. And so it's important to understand as you are engaging in this project, whether you are achieving your strategic business goals, not just whether you're achieving your technology goals. I'm gonna do something amazing and end the talk right on time. But I think we might have one more minute for questions. I'll let the team tell me whether that's true or not.
Absolutely, yeah, we got time for a question.
Yes, right in front. Sure. Question was, if we're speaking specifically about agents, does my advice change? I think there is probably more to factor out in terms of the inputs and the separation of concerns there, more than just the prompt itself. But I do think off the top of my head that the lessons probably generalize pretty well, just in terms of you're taking a business and technology dependency on an external API, therefore how should we manage this to achieve our strategic goals?